other stuff.
The
General solution.
The one quick thing I wanted to show you guys with some of these, when you have the embedded values, when you have the stuff that's embedded within, as far as trying to figure out what your A, B, H, and K, and all that kind of junk's going to wind up being, what you want to be able to do is understand that as you factor something out, it's very easy to double check yourself to see if you were correct in how you factor something through. I was just showing Shimke this, and basically everybody else. It's a nice little shortcut. In this case here, you got to pull a 3 out, okay? So if you pull a 3 out to get your B value, in order for me to put this back in, it has to wind up equaling 7 pi over 4. So that means that I need to figure out what to multiply that by to make sure that it equals that. So in order to multiply it, I got to multiply it by 1/3. So if the number is in the numerator that you take out, you put it back in as its fractional version, as a third. Whereas I think the other question where you had to take a 1/3 out, you put the 3 in the numerator. So if the 3 is in the numerator, you put it back in as a 1/3. If it was a 1/2 theta and you take out a half, you got to put in a 2 to the numerator. That's the nice little shortcut for those. Okay, that's the nice little shortcut. Does that make sense on that? It's nice. It's very, very nice when we remember that out. Yes, sir.
For number.
Are you on the graphs or the equations?
The equation.
All right, what do you got?
Number 6.
Okay. The right column, I think I told you guys to do general. The left column was interval.
Other way.
Oh, right. Okay.
General.
Okay. So this means we're doing this on the interval?
Yes.
So when you're doing something on the interval, it means you list out all your answers. Subtract 4, divide by 2, you get 0. Cotangent is the inverse of what? Reciprocal it. So use a reciprocal property, you get undefined is tangent. Where's tangent undefined? Pi over 2, and?
That's undefined.
Oh,
There's your answer.
Wow.
Yes, ma'am.
When do you want us to use the plus pi over 2?
If it says general solution, you use the end, stuff at the ends. If it says on the interval, it just means list everything out. Yeah, no, I guess that's good. Oh.
also number 5.
Hey, Mr. Murphy, is this our review packet, tech air quotes review packet?
Yeah,
Razor. Calculators.
it's all non-calculator. Subtract 3, divide by -1. I get -2 is my cosecant. Reciprocal property again. Okay, reciprocal property, we get -1/2 is sine. So that means what angle has a sine value of -1/2? Well, sine's negative in quadrants 3 and 4. 1 over 2 is a 30 degrees, so it's a pi over 6. So the two values I'm going to get are going to be at 7 pi over 6 and 11 pi over 6. Now, both of those, this is the general solution column. So both of those, since there's no exact same value to get back and forth between the two, get a plus 2 pi n. Okay?
If it had been plus minus, would you have also run off?
Yeah.
Okay, so plus minus always have plus 2 pi n.
Huh?
So like, if it was plus minus, you would do 7 pi over 6 plus pi and 11 pi over 6 plus pi.
Correct. But in this case here, since it's just negative one, you'd have to have a plus, you'd have to take a square root to get that.
Yeah, because that was other problem.
I got you. Mr. Pope.
Never mind. I was talking about how would we write it if we were doing plus pi n one.
Oh, if it's a plus pi n one, that's usually when they're directly across from one another. You see that a lot with tangents, and then you'll see that a lot when you have to take a square root, and you wind up all four of them. That's usually when you see the plus pi n's.
So we wouldn't do that otherwise. What is that if it's not?
The 2 pi n, because they're not directly across from one another in opposite
Okay,
quadrants.
so it's 2 pi n if we have to go all the way around, but.
Correct. And remember, don't pigeonhole it to be the same thing every time, though. Every one of them is a little bit different. Okay, every one's a little bit different. You have to look
I
at
just
the.
don't know.
That's why you got to continually draw it out. All right, you got to draw it out and look at where things are. Are they across from one another? Are they next to each other? Are they in different quadrants? Things like that. Okay. Yes, sir.
I don't know if this is a stupid question, but can you get extraneous solutions for general solution? Or even, I don't know, for any solution?
Yes.
Yeah.
Yes, you can. Yes, you can. For example, let's say you had a general solution and you wound up with the sine. What angle has a sine of 2? That's a no solution.
So that's it?
Yeah.
Yeah, no, I understand why, I'm just saying that's.
Yeah, it'd just be no solution. So you could you could go through the whole rigmarole of setting it up and solving it out and wind up with nothing.
Right.
Does that make sense?
Yeah.
It's not a dumb question. It's a very good question because it happens.
Good.
It happens a lot sometimes when you have the factoring problem where you have to factor something out and you get two different values. One of them works and the other one doesn't.
So don't be worried if you go through all this work just to find it's a no solution.
It does happen. It does happen, yeah.
All right.
But double check it. Make sure you didn't screw up somewhere.
Okay.
Yes, Ricky.
Do you do that number 3 on the?
Yes. Are there, let me get, see, are there any other questions on the graphs or on the solving the equations? Yes, ma'am.
Are we gonna have to do this weird stuff?
We're getting there. Any other questions on the graphs
Oh,
or the
well, I thought that
I mean, I'm
counted
sorry,
as
the graphene.
Okay.
Yes, ma'am.
Okay, for cosine, it equals 180 and number 8. Is it just pi or is it also 2 pi?
Where are you getting 100?
It's cos negative 1.
180? What is this 180? What's this degree thing? That's weird. So it's secant of theta is -1, so it's cosine. So where is your x value -1? Only at pi. That's on harassing her. She had
So it would be
it.
plus.
And this would be plus 2 pi n. Oh, is it an interval one?
Yeah.
Whatever. Okay. Let's look at the one you're talking about there, Shinky. That was this one here. So as we get into this one, I talked about this with third hour a lot today about writing how we go back and write equations and looking at things like this. Now, in this case here, they want you to write this as a cosine, or excuse me, as a sine graph. You really, well, I mean, you could, but this is very tricky to write as a sine graph, considering the fact that it's setting you up as a cosine graph. Remember when we talked about this the other day, about how we're able to distinguish between a sine graph versus a cosine graph? Your sine graphs started at 0, went to the A, 0, that opposite A, 0. Your sine graphs touch the same spot 3 spots within one period. Whereas the cosine graph, yes sir?
So if it tells us to solve for, let's say, a sine graph, and we solve for a cosine graph, that would be wrong.
Well, here's the thing. You can still do it, but you have to shift it. If it's a cosine graph, you're touching the same spot only twice. But remember, a sine graph is a cosine graph that's shifted 90 degrees over.
I think he was talking about like on a test, like saying
Yeah.
the one you just gave us. If we solve for a sine graph, but it says solve for cosine, that's what I'm saying.
And that's where I'm leading towards here.
Oh.
Okay. No, it's okay. It's okay because when you look at this one, if I give you that graph and it looked like that, I would tell you cosine. Okay? I would tell you cosine. I wouldn't tell you to do this as a sine graph. Now, if I ask you to write it in terms of a sine graph, or I ask you in terms of a cosine graph, that means I'm just going to give you the one graph. And then you're going to figure out your period and work your way backwards off of that. Now, if I don't tell you what graph it is, whether it's a sine or a cosine graph, I will give you the parent function as well as the shifted function. That way you can see how things have been mirrored off of one another. Does that make sense? Because I believe that if I don't tell you what it is, it leaves too much room. For example, if you guys go to the last page of these graph ones, there are so many different ways we can write these graphs. There's so many different ones. And I think that it's with too many possibilities out there, I want to kind of nip it to just within one period's worth of stuff, show you the parent, show you the shift, and let you decide and let you go from there, instead of giving you too much option. Because I know if I give you too much option, you might get messed up. Does that make sense?
Yes.
So for this one on 3 here, I'd say, hey, let's write this as a cosine graph. And let's do it that way. Okay? Yeah, Belle?
The space shift? Does
Yes, it means
shift
H.
stand for it's H?
Yep.
Okay.
Now, the reason again why I'm saying that this is a cosine graph is because it touches the same spot twice, and it also has 2 A values and 1 opposite A value. Just like you would in a cosine graph. Start at your A, rotate through your 0, and come back up to A. Now, this is obviously telling me that my 0 line moved up. Where did it move up to? So what's your K value? It's 3. So I know this is going to be a cosine graph plus a 3 and go from there. I just start with that. Now I know that they give me my period. My period ends at 6 pi, started at 0. So my period is 6 pi. So I set that equal to, that. Because how do you find period in a cosine graph? It's 2 pi over b. Also, I'm going to make sure that your b values are going to be positive. You don't have to worry about that. A values, it could be an inverted graph. That's not a big deal, but b values will always be positive, okay? So you don't have to worry about it. What's b going to have to be here, guys? 1/3, good. It's going to be 1/3. Now, is there a phase shift? Is there a horizontal shift to this at all? No. So I know now that I have a 1/3 x plus a 3, but now I just have to figure out what the a value is. So this, since this is my 0 line, cosine starts at your a value. Well, how much did it go up from the 0 line? 2. So my a value is 2.
Oh.
How far up is the a value from your 0 line? 2. As a sine graph? If this was a sine graph, we'd have to bring this back to here. So then we would say that it's just moved left pi over 2. So I would keep the same values for a, b, and k, but an h value would be minus pi over 2. That's it. Remember, sine graph is just a shift to cosine 90 degrees, just pi over 2. Yes, sir?
Okay, so how can you get phase shift again?
Phase shift is your H, is your horizontal, your H, your left and right shift. They just called it, I got these problems from a pre-calc book, and pre-calc call it phase shift, as opposed to here we just call it your horizontal or your vertical shift. That's the B value. Remember, your period comes from 2 pi over B. And then if you're given your graph cycles through it within 6 pi, that means your period was 6 pi. So to figure out how, that just means it was stretched. So you have to figure out what was the B value to create it to the 6 pi.
The 2 pi would be
Equals 6 pi. Yep, that's all it is. That's all. Okay? Station key? Sure. So this one, again, I think they told you to go as a cosine of that. Yes, sir.
Before we start that with so when you find b, is it 1/3 or 1/3 pi?
1/3. Because you said it equal, you had 2 pi over b equaled 6 pi. So if you flip them, the pi's drop, and you get 2 over 6, which gives you the third. I think they said to go as a cosine of this one. So if you go as a cosine, you're starting here, opposite A, and you're back to here. So that tells you your period is 2 pi, so that it's an easy b value.
So this is not shift. Because it's not gonna lie.
I did this one Friday.
Did we?
I could also write this as an inverted shifted cosine if I wanted as well. Because you could say that you started here, and you went up first, and then down and through. And that's the idea. If you have too many options when you're given a multiple period, you don't know where to start. And I don't want you guys to get overwhelmed by seeing too much. I would give you a period. I'd give you a period. Or I'll give you a parent and a shift. Yours.
I was gonna say, as long as it's like, it says if it's cosine or sine, I think we should get it. Like, you said you're just gonna use periods.
Yeah, or if it says cosine or sine, you'll be fine. And just like we were saying here, I could say that this is a positive a value because it started at 0 and worked its way through. I could shift it over to the right and make it a negative a because it starts at the bottom and works its way up. There's a couple of different ways of going about it. By giving you just a smaller chunk of it, it's less work. I don't think we need to, like I said, I don't think you need to be overwhelmed with too much of it. All right? We can get it on each of them.
So if it was inverted, it'd just be a negative a.
Yes, sir.
So if you could make it how you, if you didn't have like a parameter set for what period you're using or whatever, you could just, if you wanted to make it a different thing, you just use a different, like if you wanted to solve
Those
it,
things, yes.
If you wanted to solve it a different way, you just use a different parameter. You could solve
Yeah.
it that way.
Yeah, and like I was saying, guys, if I wanted you guys to write this as a negative, I would have done this as far as a parent graph. Something like that, and then all of a sudden it's a shifted version or whatever. You'll see the differences. Okay? Actually, I should have flipped the other one first, but you get the idea. I would have put both of that on there. Okay.
Did we do solving triggering equations last chapter?
This check. That was 14.4.
That's the front of the packet.
What was the other one I wanted to show you guys?
It's horizontal.
Yeah, can I steal yours real quick?
Sure.
I don't have this last page on mine.
The first one.
On this trig graph one, I'm gonna look at the one on the bottom of that front page. Okay. I don't have this for some reason. I forgot to save this. I grabbed this off. I borrowed this off the internet.
Wait, did you give it credit?
Yes, it
Probably
says
cite
somewhere.
your sources.
Somewhere. Yeah, I don't know why they're in decimals. Who uses decimals?
True, good point.
Oh, yeah. What? Wait, what was that?
Mr. Murphy, why did you write those values?
Not the decimals? Because I've never used a decimal before.
No, but why those values for these decimals?
Those, well, negative 0.25 pi is negative pi over 4.
Oh, these.
I'm on the, oh, you're on the very back, on the page prior to that, sorry. So, in this case here, this is what they're giving you. Oops, wow. Let me try that again. So here it's a matter of which graph do you want to call it. Do you want to call it a sine or do you want to call it a cosine?
Cosine.
It's a sign.
I'm going to say use a sine anyway.
No, it
Sine's
says
always
a sign.
better.
No, there you go. The reason,
It's in the term
We're on the bottom
sign
one.
function, the bottom.
Are we on the first page, Sam, like the second? Oh, this is the first.
I can
First
see it
page.
being shifted in a negative 3 pi over 4.
you can do a couple of different things here. Now, if I shift it, if I want to take this as a sine graph, one of the things that I can do is I can write it as, did I miss a, did I put down the value? Oh yeah, I have it. Yes, I'm sorry. I thought I wrote down the wrong value there. Okay, so if I'm looking at this, I can say this is a sine graph. The reason why I would say it's a sine graph is because it goes through the 0 line multiple times. Plus, notice there's no vertical shift because your highest value is a 2, your lowest value is a -2. That means my amplitude is 2. So whether or not I want to write it as a positive A or a negative A, it's up to me. I'm going to go with the negative A and shift it right. And then I'll do the same thing with a positive A and shift it left. Excuse me. Shift it. Negative A, I'm going to shift it left. Positive A, I'm going to shift it right. I'm going to say my first one I'm going to say starts here.
But on the test, you don't have to. You don't have to.
It depends on the problem. Okay? So if I say it's starting here, it cycles through the period between -3 pi over 4 and 5 pi over 4. How far apart are those 2 points? 2 pi, very good. They're 2 pi apart. Are we okay with that? They're 2 pi apart, so therefore what is your B value? 1. I'm going to call this a negative A value, so I'm going to move down first and then come back up. I move down how far off of 0? 2. I'll call it a -2. I moved it to the left 3 pi over 4 from 0. So what is my H? Plus 3 pi over 4. There's one of my answers. If I do it the other way and I want to start at pi over 4 and end at 9 pi over 4, I move up first and then I move down. I still have a period of 2 pi. I still have a B value of 1. I'm moving up first on that cycle, so I'll see my A value is +2 now. And how far off of 0 did I move it? So it's going to be x plus pi over 4 or x minus pi over 4. Both of these graphs are the exact same. They're the exact same graph. It's just whether or not you wanted to start it with a negative A or a positive A. Totally up to you. But in this case, you'd be given this much and say, hey, write it as a sine graph. There's only 2 ways to do the sine graph like this. Okay? You can do the same thing with a cosine. I could have done it that way as well. I could have a cosine shifted over to 5 pi over 4 to the left, positive A value. Could have had a cosine graph shifted to negative pi over 4 with a negative A value. Shimki, no, get you next guy.
This is kind of, okay, so you know how you talked about like flipping them? Like if they started, how do you like do you just, so if it like start out negative, does it then become positive A value or what happens?
Okay, your A values tell you the direction to go. Sine graphs start at 0, go to their A value, whether it's positive or it's negative. So if I'm starting at -3 pi over 4 and I'm calling it a sine graph, my next move is down. That means it's a negative A.
Okay, but I'm saying if you were to flip it, like you know how like equations where you like flipped it?
Oh, reciprocals? Oh,
Yeah.
cosecants?
No. You flipped it.
Oh,
like,
reflected. Okay.
reflected.
Yes. That means your A value becomes negative. So if I
Wait.
give you,
So wait.
you're thinking about the word problem where it was shifted and then you're reflected
Yeah.
over the axis. Okay. then you would just, if the original graph was a positive, if it's flipped it over something, it just becomes negative.
Okay.
That's it. That's all that is. I don't know. It's very interesting. Mr. Mack.
On the test, will we ever have to find more than one equation for a single graph?
No, that's really, really mean. I mean, you could.
Don't give them any funny ideas.
It's true. I got a whole extra page I can add to this.
That's not.
I'm so jealous though. You like were the last person to leave the school because you had time to put your jacket on. When we-
Oh, yeah, the fire drill?
Yeah, you were the last person.
No, I was standing up here at the door and I was talking to Lockhart.
What if it was a real fire? Would you go and still talk about hard?
Probably.
What is doing fire?
Miss Bella. Yes, ma'am. Other parts of the test. Test is about 11 questions.
All right. All graphing.
That's not good.
Yeah. All graphing multiple choice with the calculator. Good luck. So, you're going to have, yeah, you can wish, exactly. You're going to have, I'll tell you this for certain. 2 simplify, 2 verify,
That's awful.
2 general, 2 interval, and it leaves you 3 for graphing.
That's simplified. Oh, that's dead. I'm gonna already.
Wait, is there gonna be tangent graphs?
Yeah.
There might be.
So I know what.
Can we do like 2 simplify, 2 verify? Like
Pick one.
Oh, sure. Let's get it. 2 simplified.
Oh wait, so there's not gonna be.
What do you got?
No, I'm just counting.
Do you need your toes still?
Oh, no.
Because you are going to 11. I don't think you're Antonio Alfonseca, are you? You're not missing a, you don't have an extra digit.
3. 2 general.
I do.
2 verify. 2 interval. 4 graphic.
To be honest, I have it up. I have that sheet here. Which one you're looking at, sir?
I was just gonna circle 4 of them.
Okay, no one can
okay.
add that.
Here we go.
Do 28. And
28?
Oh no. Yeah, 28.
Yes.
Now there are a couple of trick ones that are thrown in here.
Yeah, that's verified.
And one of the things that I would tell you guys,
Oh, not this again.
Not this stuff.
remember, simplify and verify, you're doing the same stuff. One of them just tells you what the answer, the other one doesn't.
Oh, right.
You still go through the same process.
Well, you already have
One of the things that I would do, whenever I have addition, I'm automatically going to rewrite them as fractions to try and get common denominators. So if I start with, secant plus tangent, I'm going to rewrite that numerator as 1 over cosine plus sine over cosine. And then I'm going to go back and take care of the other denominator part in a minute. 1 over cosine, sine over cosine. Do they have the same denominator?
Yes.
Yeah.
Yes. So this means I can put them together and get 1 plus sine over cosine. So far, so good?
Yeah.
Do the same thing with the denominator. I have cosine plus cosine over sine. These guys do not have the same denominator. The common one is going to be sine. So the common denominator here is going to be a sine. Now, fraction on the left needs 1. Fraction on the right doesn't. So I get that. So I take the top one, and I'm going to multiply it by the reciprocal of the bottom one. Okay? I'm going to rewrite that. 1 plus sine over cosine times sine over sine. Oops.
Is it
Right.
sine, cosine plus cosine, or is it plus 1?
It's sine, cosine, plus cosine. I cannot because of the addition. But on that lower right-hand cornered one, what do those two terms have in common on the denominator? Factor out 1 cosine.
When you factor that, does it go away?
No, you get 1 plus sine over cosine. I get that. And now I can simplify out the 1 plus, I can simplify out the 1 plus signs because they're terms, okay? So I can simplify that out. And I now have sine over cosine squared, which wanted me to write it as sine secant squared.
Oh no, this wasn't on the cosine.
Now another thing that this sometimes happens with a problem like this, cosine squared is the same thing as cosine cosine. So you probably could have written it like this as well. Sometimes if you have to split something apart when it's squared, you can do that step as well. Okay. Yes, sir.
How come you can't cross off the signs?
Because of that.
How do you get the second sine plus 1? Is that one of the, that's one of the thingies? What you call it?
Factor that with cosine.
Oh, sine.
Yeah, this, since this right here, this is x, y plus y, and I factored out a y, and I got x plus 1.
Oh, okay.
That's all it was, guys. Thank you, sir.
No, this is not, this doesn't even look simple when it goes over. It's still.
Can you do some more of those?
What's the other one I wanted to, there was another one I wanted to show you.
49?
Which one? 49.
Do one of them to the test.
There are still 49.
We're not gonna.
Oh.
I say do one of them to the test because we're not gonna remember it regardless.
Can you do number 2?
This one? No, this is a really good one. This is a really good one. I'm glad you asked for this. One of the tricks that come up pretty often is that when you have more terms in the numerator than you do in the denominator, when they're separated with addition or subtraction, rewrite them as multiple fractions. That just means that the sine is a common denominator of both the cosine and the tangent. Split them apart. You get cosine over sine plus tangent over sine. What's cosine over sine?
Tangent.
Oh.
This becomes sine over cosine times 1 over, oh, sorry.
No.
Oh, what's right?
No, go 1 year before. Cosine over sine is cotangent.
Yeah.
Oh, thank you. I was getting ahead of myself on the other stuff. So yeah, sorry, this is cotangent, excuse me. Now the other one, I split it apart as sine over cosine times 1 over sine. It is. I accidentally wrote it wrong. I was looking at tangent, I just wrote tangent by mistake. Okay. So the signs in this case drop. I get 1 over cosine, which is and there it is. It's a great trick to remember that when you have that common denominator, you can split it into the other fractions just to make it simplify itself through. Okay. Another great trick that you see quite often is when you have addition to multiplication. That meant you had to get a common denominator. All right. When you see the addition jump to multiplication, you get a common denominator. I know you're still looking at that, Mr. Pope. You got it okay? Where are you at?
Are you good?
You okay where I split it into the 2 parts?
Yeah, I got that
Okay.
part.
Cosine over sine is cotangent?
Oh. I thought the
You went,
sign-
yes, I went
thought
this way.
Okay, let me take another look at that then.
Pardon the interruption. The juniors have been released from the
Wait,
presentation.
Mr. Murphy, go
Watch
back.
out!
One second. I'll go back.
The doors.
Yeah, this is a lot.
Done.
This is a lot.
Tangent over sine over cosine times 1 over sine.
I simplified this here, and I just rewrote this over here to write it here. I did them out of sequence.
Wait, tangent over.
This is sine over cosine times 1 over sine.
Oh, gotcha.
That's where I got. All right. Where was it? 29.
Wait, this is not one worksheet thing.
Yeah. Another one. A little bit more complex.
A little bit.
So in this case here, take a look at what you have. You're starting with the quantity 1 plus sine squared over cosine squared, and it wants you to write it as 1 plus sine over 1 minus sine. So when you have junk squared, what does that mean? Junk times junk. 1 plus sine, 1 plus sine. Junk squared is junk times junk. What is cosine squared?
1 sine squared minus 1.
It's 1 minus sine squared. Is 1 a perfect square?
Yes.
Is sine squared a perfect
Yes.
square? Is that a subtraction symbol?
It's 1 plus sine 1 minus
For what? Nope. Junk squared is junk times junk.
This is the type of problem you look at for a while and you figure it out, but you already wasted all your time with it.
I didn't foil it. You're making it harder than you need to.
This is exactly what's saying.
Isn't this Isn't it that?
You suddenly find out the answer.
I'm just doing it this way because now I have a difference of squares, so I get and now they drop. Because this is the difference of squares where this was
It's
just
1 perfect
junk
square.
and that's all.
Sine squared squared.
It's a nice trick. It's a great
1
trick.
sine and 1 minus sine.
Okay.
I know. This is close.
No, it's more like, am I even close? So far away.
What was the other one? Wait, what was your
The juniors are in.
So this one here, this is forcing you guys. So this one's forcing you to get a common denominator. Okay. My common denominator here is going to be 1 minus cosine, 1 plus cosine. Okay. Fraction on the left needs a.
What?
1 plus cosine.
Fraction on the right needs a.
1 minus cosine.
What's 1 plus 1?
1. 2.
I should smack all of you.
So let's try this again. What's 1 plus 1? 2. What's cosine minus cosine?
0.
That means 0.
If I FOIL that out, what do I get?
1 minus cosine squared.
Which is?
Sine squared. Which is?
Wait, Mr. Murphy, you are killing puppies by adding the 1 and 1. That's not killing puppies.
No, killing puppies is when you take junk and square it and not multiply it out twice. Let's see, what was the other? There was another one on here. I'm trying to remember. A lot of these are incredible.
Mr. Shakir would be pretty upset about it. And then to go to make a documentary. Bring Dr. Green.
Think of anything else? These are more problems than ever. You guys can have as many of these.
Wait, is the screen recording right now?
Yeah.
So we can go back. Why are you taking home class?
This one's pretty cool.
She'll buy the
It's a different way to spell tiny. Tiny, tanny.
So if you go this route, again, you're setting yourself up. You've got a bunch of reciprocal things. Your best bet might be to go ahead and work with the numerator first. Or maybe multiply by its conjugate. I mean, that might work as well. It's totally up to you when you get to this part. Now, if I multiply by the conjugate, I get 1 minus secant, that'd be 1 minus secant squared, and I don't think 1 minus secant squared got us anything. It was 1 plus tangent squared of secant. And then we wind up with a negative tangent, and that's not going to help us at all. So what I'm going to do is do the whole idea of numerator, common denominator, denominator, common denominator. So I'm going to have sine over 1 plus sine over cosine all over 1 plus 1 over cosine. Be okay with that?
Yeah.
Yes.
Bless you. Let's get the common denominators going. On the top, what do you get?
Yeah.
Here, the common denominator is going to be cosine. So it's going to be sine cosine plus sine. Down here again, it's going to be cosine. And the numerator is going to be cosine plus 1. Everybody okay with that?
Yes.
So now I'm going to rewrite the numerator multiplied by the reciprocal of that denominator. Which means this top left numerator, what can I take out? I can factor out a sine. So if I factor out a sine, I get cosine plus 1.
Plus 1. Snap.
You get one.
And you get sine. So a lot of times it looks like it's going to be awful.
And it did.
It was pretty awful. But guys, remember, take your time, go through this stuff. You know, you've got 2 simplified, 2 verified, 2 general, 2 regulars, couple graphing. All right, and 48 minutes to complete. Yes, ma'am.
She wants that homework.
No, study it, do all that, and we'll go from there later.
Okay, well, I have homework coming on Saturday.
This wasn't verified.
Murphy has homework on the day I was absent, so